Hello everyone, I am Tahir Abbas Johar from Team B and this is our midterm presentation. The contents for my presentation are as follows: development approach, sketch, extrude, unity primitives, Lego based, ProBuilder based primitives, unity, CSG operations, scenario, job allocation and schedule. I will start from the development approach. There are two streams, one that is taught in our class and the other that methods we found on our own. In class taught methods we have sketch, extrude and unity primitives. In other methods we have Lego based primitives approach, ProBuilder based primitives and unity primitives CSG operations. First with the sketch, for up till now we have made a rectangular sketch and then the user can confirm or cancel the sketch and then it goes for the extrude. So it looks like this. So it is like so it is confirmed, and next is extrude. Based on the particular sketch we can make the extrude. So the user can select the sketch and then allow the option to extrude, and the input can be made via the slide, and there can be possible implementation like manually inputting the height parameters. So this is for extrude. User selects the sketch and then hits the extrude, and so it is like this. So next are unity primitives. For the time being we have just make functions that make primitives. So there are mainly four types of primitives in unity. We have skipped quad and plane and used cube, sphere, cylinder and capsule, and these can be used for other operations. So here it makes a capsule and you can, and then it is just a UI but there is no manual input yet, and then you can make a sphere with it. And this cylinder is not based on the unity primitives, it is another approach I will explain later. So the next is the Lego based. In this method we try to make the geometry by adding primitives. So in this way you can make a slot, make a plate which has a slot like this. So instead of applying operations like remove the material, because mesh has problems, so we can make such kind of shape with this approach. And next is ProBuilder based primitives. ProBuilder is a unique hybrid of 3D modeling design and optimized for building simple geometry in the Unity. It is now available as an asset, and it is also based on the procedural modeling approach. And as per the Unity, they say that it will be available within the Unity by 2019 release. So for the Pro Builder we did some implementations, like this type of geometry can be made. This is a prism. So we can make something like this just by combining the primitives. Next are the Unity CSG operations. By CSG operations I mean union subtraction, but there is problem with CSG operations. When such an operation is applied, Unity forms the mesh again, but that mesh is very bad, as you can see in here, and in here there are some problems. So when this approach is continued, or you make too much remove material, there is problem. The processor cannot handle it, and especially with respect to mobile, there may be some limitations to what extent material can be removed or what kind of material can be removed. So this is the implementation for that. As you can see, these are two Unity primitives, so you can then subtract one from the other, and vice versa. So it is like this. For the scenario, we proposed an L-shaped block for the time being that can be made within the mobile environment, because there may be some build issues, so we propose small and then go for big. Next is job allocation. We divided our streams as the sketch based programming and primitive based programming. My portion is the primitive based programming, and Abhi's portion is the sketch based programming. And next we have to develop some UI inputs for each case, and then we will combine our code, and then we will go for the Android environment. So schedule is the schedule. We are at the midterm presentation. We are trying to make functions for the user input, but you cannot input a single value. So we will implement some slider based operations. I tried the inputs, as you can see in my this here. I try to implement the input by using these input boxes, but there were some errors. That is why we cannot use specific inputs, rather we will have to specify range for each case. So there are such kind of limitations. So then we will test on ourselves and we report for the final presentation. That's all. Yes.
What you want to do with the inputs on the lens, like placing the inputs on the lens, what do you want to do?
Which?
This small values, what are these for?
Actually, I tried. You are asking about this, right?
Yes.
I tried to input the value for cube using these inputs. Like there is a rectangle, and I would like to specify that in X it should be this, Y should be this, and Z should be this. But when I try to call these, into the rectangle, there were some errors. And what I have seen that, as shown by the TA, you cannot put some value directly for the mesh operation. There should be some slider, like there should be a small value already input and you can just vary. So I will go for that next. Yes.
So you guys plan to use this sort of Lego building block method and also the Pro Builder subtraction method to create holes?
Actually, this method is not the Pro Builder method. It is Unity's method. There is also Pro Builder's method, but I tried to implement that one as well. There were some problems because Pro Builder is in the development stage and there are no API documentation. So why we used both the approach, because we can use the sketch to make some geometry, and then for removing out of it we will need some primitive geometry like stamping. We have a source plate and we stamp out. So that is the idea for using the both. Yes.
For the does it go block by block?
For the Lego base, yes, it goes by block by block, as you can see. In this case, you can just click on each face and it makes up the geometry. So it is like going one by one, but it is very time consuming and maybe cause problems.
And so you show your sketch pictures, so just only rectangle.
Right.
Is there any other sketch geometry?
Not yet.
None yet, or no plan?
Not yet.
None yet.
Maybe we implement. Maybe you can.
The code was created to be as modularized as possible. So, like when a different geometry is sketched, we just have to transfer the vertices position information to the extrude function, so it will extrude the same shape.
I think in today's presentation, your team, I think your team focus on using primitives. So and then use the Boolean operation to make some new things. You know that. But as you know, the CSG method has some limited to make some complex model, because in CSG method just primitives, cylinders, cube, brush, and others. So how to cover to make some complex model in your method?
Actually, idea is to use both sketch and extrude, and then use primitives to remove the geometry.
And I missed your scenario slide.
Yeah, scenario is not very. Yeah.
So you make air block model.
Yeah. We defined it simple because I tried to export the application for mobile, but there were some build issues due to the environment. For the time being, all these implementations are in Windows environment.
So in this air block, so your system make polyline or make blocks? Use polyline sketch or use block primitives? Which one? Use sketch to make that is polyline.
with the ProBuilder approach, there's the method where you just click on certain points to create vertices.
Okay.
Yeah, then once the maybe a closed space, closed plane is defined, then the vertices will form the plane, the shape. And then maybe from that plane we can extrude to form the block.
So you mean the make using 1, 2, 3, 4, 5, 6 vertices,
Yeah, six
and then
the
make
block.
that shape of
Yeah.
cat, and then extrude.
Yes.
How about the implementation on cut extrude?
As I showed, for this kind of scenario, we have to pass those game objects to Unity and then check if it works or not. Because as I have researched, there are some issues with cut extrude because it is all mesh based. So whenever a cut is performed, mesh is distorted, like you can see here. Mesh is very bad. So we are not sure even that the phone will be able to process this type of information on.
That's all.
Right. In the proposal, you may show us target or goal, and I suggest to have two different targets. One take the core target and the other additional target. I cannot see any division, or is it the same as proposal stage, or you have some good changes or target?
No changes in the target.
What was that?
It was, main goal was to use sketch to extrude, and additional goal was to remove material.
Right. And second one is demonstration scenario. This is demonstration scenario, right?
You're right.
So I can ask you what you will show us. The demonstration.
We
Just
will,
making a block.
yes.
That's it.
For the time being, that's it.
All right. And using your smartphone or how do you
It's
show?
smartphone. We will show via
Sure.
smartphone.
I want to see the hardware specification. Steps of
Implementation environment.
right. Implementation scenario includes what kind of device you are using and what kind of tool and what can be the steps. The final goal should be developed. Also, right? And so this question is about, do you use any open source in the project?
ProBuilder is open source.
So will you combine this one to your project?
Yes.
I can see, you just showed, there is a ProBuilder. What is your plan to combine them into your project? So I want to see that kind of thing, right? Finally, I guess every team will upload your development source code into GitHub. Right? Okay, thank you.
So, hello everyone, welcome. So I'll present our midterm presentation for this project, Group C, which is made of Muhtar and myself. So, here's the contents of this presentation. So let's start with a schedule revision. That was our original schedule, and we just painted green what we've actually done yet. So we can see that we're about what we expected to do. We have done some. We have done the sketches. We have done the 3D geometry we wanted to do. So we'll see that in detail. So for this project, we've used Unity, only Unity. 90% of the code has been made from scratch. We don't use another open source material. And most tests are done in the Unity editor itself. But we also use sometimes Unity Remote, which is an app for mobile. You plug your phone to your desktop, and when you run the editor in Unity, it projects on the phone what's in the editor, and so you can try the inputs to register you can try to play the app on the phone. But if you want to use that, you have to be aware that the UI would be deformed. So that's why I said here. And if you want to try the real stuff, you still have to export an APK file to your phone and run it directly on your phone. So let's see our progress. We have coded camera movements if you want to watch our geometry from different angles. So we have panning and zooming. That's what you see here. We're able to select planes, as you can see here. This is not as easy as it sounds. Just be some difficulties with it. And we're also able to draw sketches on this plane, to draw different shapes. We have rectangles, we have circles, and as you can see here, when we draw a rectangle, you have the dimensions that show up, and then you can edit the dimension by just making a keyboard input. Because we are on mobile, and so the precision is not great when you want to draw. So that's why we use this approach of using input via keyboard. And also sketch can be deleted. That's it. We're also able to extrude these sketches into 3D geometry. We'll see that later. And also for the extrusion, we choose to have a keyboard input for the length, just also for precision. And also, you've noticed we have some menus that work that go on and off screen. Because we work on mobile, we want to we have a small screen, right? So we want to save as much screen as possible, as much screen space as possible, while having big buttons. So that's why you have to like hide and the menus when you work in the project, making everything visible, everything that's needed visible. And yeah, you're also able to hide all menus if you want to take screenshots, if you want to share the project. And also with the menus like going smoothly to have a satisfying experience. So that's what that was about UI and UX. Now about geometry kernel, we have used the mesh triangulator and mesh extrusion codes we were providing during class. So we start from the sketch, which is a line renderer object in Unity, and then we extract the critical points of this sketch to conserve the geometry, and then using the triangulator we make a triangulated mesh out of the sketch, and then we extrude. So here's a small demo video of a whole process. So first off, want to select a plane, maybe draw something on it, maybe delete it because that wasn't what you want. Draw on another plane, can change the radius, and maybe then extrude. So you can see on the left you have the cylinder, change the extrusion length, and maybe draw something else on another plane, change again some dimensions, then extrude again. You can see it on the left. and you can hide the menus to take a screenshot or something. So I want to point out some features that aren't that obvious in Unity, like for instance, maybe being able to have some inputs for profile, for the dimensions in the profile, or extrusion, to be able to delete some sketches, to be able to pan and zoom to move the camera around. And this was tricky, like plane selection and visualization from both sides, because there were some challenges. So because Unity is a game engine, its assets and components didn't really fit our purpose. So, for instance, the planes you saw, these are planes primitives in Unity, and they are quite weird because they are visible and interactable only from one side. So that was quite a tricky problem to solve, but to make clones and whatnot for the selection to work. Same selection of a plane is not. There's no built-in code for this, so we have to make selection using raycasting from the mouse position into the 3D world and get that object that's been selected and stuff. Also, learning C# and how to use Unity while coding the project does produce some problems like poor software architecture and unoptimized code. So we may have to go back on these old lines maybe to optimize and to run better on Android. And so also we had to deal with the issue of multiple people working on the same code. So what's next? First we have to implement the control scheme and design and implement the control schemes for Android. So adapt the whole code to integrate touch inputs and multi-touch inputs. We want also to be able, because you saw we only drew on existing planes, but now we want to draw like you would do in actual CAD systems. You have a geometry you've extruded and you want to draw on that geometry, muted geometry. So this will be quite tricky, but we want to do this. And then also some debugging and optimization. And also a reminder of our secondary goal. We may want to add cut extrude if we manage to have the time for that, and sweep also. And these are F references, and just a reminder of the future schedule. So that's it. Any questions?
No question?
So you guys will use rectangle and circle geometry only, or would you add something more?
We may want to add a polygon-based, like where you decide the amount of edges you want to input. So you can make triangles, you can make pentagons and stuff like that. We may want to add that.
Do you have to, any plan how to implement cut extrude?
Not yet. We have not really looked into the code of this.
Yeah.
On your team, ask if the software or smartphone.
Yeah, we've done some we've done some tests with touch, but we've seen that the UI was totally deformed. So this helped us tracking this issue. So we solved it, and since then, not yet. We have not know the
Is
test.
pictures coming from your smartphone?
This is coming from the editor, and it's just button. It just
Anyway, is
screenshot.
this your smartphone?
This photo? No,
No.
it's a Photoshop like.
So this picture is Photoshop?
Yeah.
So I see this picture, so your team is good developer, good teacher. So oral thing, like your team is develop the oral thing or use some open source?
We've used some outside source just for the mesh triangulation and extrusion. But other than that, yeah, everything is made from scratch.
So currently your team does the camera navigation,
Yes,
panning and zoom.
yes.
So is this function by hand or on button?
Currently it's made by dragging the mouse, but it just works the same as if you're dragging your finger around the screen. So-
Your team should implement,
Yes.
will implement the motion gesture, finger gesture.
Yeah, that's the next step.
I think the previous thing also said the finger gesture, so in finger gesture, the precision is, I think, the problem. So
Yes.
You adjust some parameters to some guy move two fingers, some software is too large the tuning or too large zoom out. So you should adjust some parameters.
Yeah, some tweaking.
And is there scenario?
Not yet.
I think you think should make a scenario.
Okay.
Thank you.
Yes.
You mentioned using ray test, right, to maybe select the game objects.
Yes.
How do you separate them from the panning motion, from the pointer for camera motion or the pointer to select the game object? Is it by Boolean or?
Well, when I want to move the camera around in the code, I make sure that I'm not on a game object, so that if I click on a game object, it doesn't move the camera, and instead it selects the object. And if I want to move the camera, like pan around, I have to click on the background.
So that one is all in one script?
Nope. I just have one. I would just yeah, there is a simple condition made if where I click I detect no game object, then okay, you can move. There is a raycast sort of process in Unity.
Then
Okay.
using Boolean for that.
Hmm?
I mean, for the raycast, you use the raycast condition for a Boolean.
Yes.
Right. So your team looks like concentrate on user interface, whereas the previous team B is concentrating on geometry and things. And so I hope you two teams can. The other comment is, it will be nice. I don't. I'm not trying to request you, but just an idea. So that we are using smartphones. So instead of changing our moving the model in this way, we may try to move camera around the object, right?
Yeah.
And then you can see it's similar to it looks like camera instead of model.
Actually, I've looked up Unity, and you can actually get the accelerator inputs from your phone accelerometer. So you could do that, I guess.
Right. I don't know how it is accurate enough to.
Yes, that's the problem.
And Professor, the problem with that maybe is like the testing in the computer.
Oh yeah.
Testing the
Testing, right.
the computer.
But it can be another mode of observation, camera mode of observation. And so same as you need to have a goal. So in the proper stage, you have two figure goals. Is it same as before, or you have changed? That is my question, and also demonstration scenario for the final presentation. Next month, what can be the final demonstration?
What?
It is similar, right? Goal can be shown in the demonstration.
Demonstration would be making a model that's made of multiple basic geometry so that you create a geometry, then you sketch on that new geometry, and so you can create an actual model like you would on CATIA or such.
Okay. So write down here.
Okay.
show to us what is your goal and demonstration scenario for final presentation.
Okay.
Great.
Good afternoon, everyone. I am Fahim Masum, and I am representing Team A, which consists of myself and Kim Hebin. So, without further ado, this is our midterm presentation. First, I will introduce by giving a review of what we talked about in our project proposal. After that, I will talk about the progress that we made since our project proposal until now. And then I will wrap up with talking about what is left to do until the end of the semester. And then I will briefly show our job allocation and our schedule. So we know that the goal of the project is to make a geometric modeling tool for our smartphone. If we recall Professor Hyungi Kim's lecture that the smartphone has certain advantages over using a laptop, and we hope to be able to make use of those advantages in our project. So we've learned about geometric modeling kernels. However, we are using this development environment called Unity, which uses C# scripts to generate mesh, which serves the purpose of 3D modeling in our project. And from using Unity, we can convert to Android or iOS output. In our last presentation, this is what we presented as our overall project goal. First, we would use finger gesture to sketch. And then once the sketch was made, we would have a library of features, 6 of them, which you can see. And then there would be some additional features such as viewing with a camera, like panning and zooming, and also image output. However, based on the feedback which we got from the students as well as the TA and professor, we modified our project goal. Our main goal is still the same, that we would sketch using finger gestures and have a library of features. As you can see, our library is smaller, and I will go into detail later. However, we hope to also be able to implement some unique features which give the phone an advantage over using a laptop. So first, we would have to make a sketch. On the computer, we use the mouse to draw lines and shapes. However, on our phone, we have to use a range of finger gestures. And this was our target features in our last presentation. We would have 6 of them: extrude, cut extrude, fillet, chamfer, revolve, and sweep. However, due to time constraints and lack of expertise, we decided that this was too much maybe, and that is why we have reduced it to these 4 features, which are extrude, cut extrude, revolve, and sweep. And we would do it for simple geometry such as circles, rectangles, and polygons. So this is now our progress that we have done. This is the user interface. On the left, similar to the previous teams, we have 3 planes to select from: the XY, the YZ, and XZ planes. And on the right, we would have some buttons which would make it easy for the user to select certain actions to do. In the following slides, I will show a series of images and video to explain. So the first thing was plane selection, and after we select the plane, we are able to make a sketch. So see, first we select, for example, the XY plane, and then we sketch the figure of our choice, and then we can go back to the menu to do the next action, which in this case is the extrude function. Once the sketch is done, we can go to the main menu and select the extrude button, which extrudes it to a certain length, and then we can adjust the length manually or on the mobile phone, perhaps using a slider. So this is the first video showing the overall mechanism, let's say. So in this video, we will be drawing a cuboid from a rectangle sketch. I actually slowed it down because I worked too fast. So once the sketch is made, we extrude. We modify it. And we, similar to the previous stream, we also want to use a camera that has panning and zooming. And we are able to change the direction. However, we do not have the zooming feature yet, which is actually very simple. We will use mouse scrolling, and we will implement that soon. The next video is to show that we didn't only do it for a rectangular cuboid model, but also for cylinder. And once this is the camera is fixed, we will move on to also drawing polygon shapes. And as you will see, we can use our camera to rotate the view as well. Like that. So these are our future plans. As Alex and Mutahar's team mentioned, that they are also looking to select faces to sketch on, because that is what you actually do on 3D modeling software instead of just drawing on a plane. So once we are able to select faces to sketch on, we will complete our remaining features, the first of which is the cut extrude. And then we will make our scenario, which is a standard part model, for the final presentation. And if there is the time, then we will try to use our additional mobile specific features. So this is the scenario. We chose a model like this because we believe it has all the different features that our app can provide, such as cuboid and cylinder, as well as extruding, cut extruding, and sweeping. And for the additional functions, we have almost completed our viewing transform. We just need to add some sort of zooming function. And we also believe that Unity has the option of viewing in landscape or portrait mode. We would also like to be able to revise the parameters once the model is made. And lastly, this is the most ambitious one, and it may not be possible, but we hope that there is some sort of way of taking an image and then recognizing shapes, which it will then import to our program. I think some of you are familiar with software that does this, like OpenCV, which recognizes geometry, but in our initial research, we found that Unity may not have the capability to do such a thing, but we hope that it will be possible. So this was the schedule we showed in our last presentation, and we are actually on schedule as of now. We finished our project proposal and making the GUI, implementing Sketch, and finishing up extruding. And after this, first we hope to do the face selection, and then finishing our remaining features. And if there is time, then implement the unique functions specific to phone. Here is the Gantt chart for the equivalent schedule showing our job allocation. We are currently here, and 4 main tasks remain. So that is it. These are our references. Thank you for listening. Any questions?
Questions?
Can you go to your scenario slide?
Which one?
Scenario.
Ah, yes.
So about the lower side on the right,
Mhm.
how you plan to add, is this first rectangle extrude and then fillet, or do you have any idea?
I think we plan the majority of this, which you're seeing, going into a different direction, is the sweep function. And after.
No, I'm just talking about the right flange.
Okay. Yeah.
So how you will implement such kind of device? It is not a square, it is something like a rhombus.
So maybe since we plan to involve sketching of simple polygon, perhaps we can use a simple rhombus sort of sketch and then extrude that.
My second question is this sweep hollow or full?
I think it will be hollow
With
because.
respect to unity,
Uh-huh.
you have to make two meshes. One is the outer, then second is the inner.
Okay.
So I tried to make half things, but it does not work. It shows as just a hollow mesh. So you may have some problem.
Yes.
Can you go to the plane section?
Yes.
Okay. So how does it select the plane?
I mean here, unlike in your case where you directly click on the plane, we have the buttons,
Okay.
and how it does is that it just pans the camera to, the button is assigned to a certain plane, and then the camera pans to that specific selected plane.
But I think that since there is no shade or something, it may be difficult to understand on which plane the actual object is.
Okay, I think that is not a very difficult fix. We can just fill the plane completely.
It was sketching in XY plane or the red plane. Why?
Oh, just example.
The example should be like XY and YZ.
Okay. Yes.
When you do rotation, it's rotation around the center points.
Yeah, we use the origin, the center, as a pivot for the camera, and we zoom or rotate around that pivot.
This is a comment, not a question. As Sahil said, for the sweep, I think it's easy to make solid sweep.
But
And something maybe already available or making all those sweeps.
This is in page 15. Yeah, you said select picture frame, selecting face to sketch form.
yes.
So it means your software can select some faces to make you sketch, right?
Yeah.
So how to define, how to select some face?
We can use edge data or vertex data maybe.
Vertex data.
Vertex. Yeah.
So the touch your screen, by screen, then the software recognize the vertices, then the face. How about latency?
Actually, there is a possibility. I hadn't thought of that until we saw Alex's video that we can use some creative methods. So yeah, maybe raycasting is one possible option for selecting the face.
So I interest in the selected phase sketch from here. And page 7, we show the gesture. So there are 6 gestures. So how many gestures in your software?
We haven't actually tested yet, but maybe most of these are, I mean, we can divide this into 2 categories. One is single finger and 2 finger. So maybe this is not exact representation of the gestures that will be available on our program, but we hope to be able to utilize both single touch, double touch.
Okay, and last one is, what is the specialty of your software compared with other teams?
I think our team is closer to the second teams than to the first, but hopefully we will be able to have some sort of additional feature that distinguishes ours from the others, such as parameter revision or maybe shape recognition or something like that.
Thanks.
Right. It seems to me that you are still working on PC, not moving to mobile. Right?
Not yet.
I think you need to move to the mobile environment as well, because it will be different.
Actually, we try to like format that for their basic because it's the prominent function.
That's it.
Yeah.
So anyway, you need more time to work with smartphone. It's, instead of PC, it is different. Right? All right. Good. So that's it. So please send the presentation file updated and
Yeah,
link right today.
I already received each team, so I don't know.
No, they may want to modify.
Yes.
So midnight tonight is deadline for verification part. Listen, and then we will make a great evaluate, right? And then see you Wednesday.